Hello and welcome to SciLux, the podcast where we talk about scientific developments and technological changes in Luxembourg. Don't forget that SciLux is powered by Research Luxembourg and we are recording in the studios of RTL City. Our guest today is Professor Christophe Ley. Christoph is Associate Professor in Applied Statistics at the University of Luxembourg. He studied at the Université Libre de Bruxelles, where he obtained his PhD. Before joining the University of Luxembourg, he was Associate Professor at Ghent University in Belgium. Among his achievements is the Prix Marie-Jean-Laurent Duhamel, rewarding the best PhD thesis in statistics over a period of 3 years among all French-speaking universities worldwide. He is president of the Luxembourg Statistical Society, president of ECAS, the European Organization for Advanced Courses in Statistics, and leader of the international network S-Training, New Data Science Methods for Sports Analytics and Sports Medicine. In his work, Christoph also focuses substantially on interdisciplinary research. Christoph, thank you very much for coming today.
Thank you very much for the invitation. I'm glad to be here.
Happy to hear. So I have to say that when I prepare descriptions of my guest, I don't necessarily focus so much on president of this and president of that, but I did it on purpose here because I just found it so interesting that there are many different societies and organizations I've never heard of. I'm very sorry, but I'm
no problem. I can understand.
I'm pretty sure that they are important. And I have to say that statistics is very dear to my heart because I am also a member of a group, completely not being a statistician. I play volleyball with statisticians.
Okay.
Did you know that there is a special kind of tournament in Europe, which is a tournament of volleyball of statisticians?
No, really?
Yes, and I should not be admitting that because it means it's for statisticians and should be only statisticians. Mm-hmm. But yes, sometimes you can bend the rules a little bit.
Yeah, sure, like twist the data, as they say, right?
But that's not what statisticians do.
Statisticians do, no.
Never.
Of course not. Never, ever.
Okay, so we start with that, actually. So statistics and data science. I have to say that. I have to just, let the elephant out of the room. Is that what you say, I think? Or cupboard, or whichever you do, whatever you do with the elephant. Statistics is data science or is not data science?
Well, this is a really good question to get started with. I like to say that data science is, in a sense, statistics 2.0. I actually wrote a paper together with a former guest of yours, Stéphane Bordas from the University of Luxembourg, where we describe what makes data science so special. And it's also been said that data science is a sexed-up term for statistics. If I tell somebody in the street that I'm a statistician, well, this person will just think, that's boring. He's just working with numbers and Excel sheets. When I'm telling the same person that I'm a data scientist, it will be like, oh, that's cool. I have no clue what it is, but it sounds so much better. While in essence, data science is really the more modern version of statistics, if you like. It brings many different disciplines together, but that is also what statistics is doing nowadays. So there is not this big difference between them. Statistics is part of data science, but data science is like your newer version of statistics. So yeah, I like to say it's statistics 2.0.
Do you have any idea why statistics has such a bad press? Because it's true that, whoever I talk to, if there is the word statistician, statistics, I don't know. Also, I was talking the other day with friends who studied some social sciences, at least in Polish universities. I'm from Poland. It is always that, oh my God, I have to pass the statistics test. It's so difficult. Why is it like this? What's the problem here? We also know that maths is a problem in general, but then we also have to discuss that math statistics, how related they are. Why is this bad press of statistics? Do you know?
Well, I think you correctly said it. Statistics is part of mathematics, and in general, there is a bad feeling towards mathematics. I think this is probably also due to the fact that it's something that many people believe that they struggle with, or they just don't see why they have to study all this mathematics at school. And so there is this negative connotation towards mathematics, and this is inherited towards statistics, which absolutely should not be the case, because mathematics and statistics, they are present in our everyday lives all the time, and we do need them. Things like proportions, percentages, or the difference between mean and median. These are notions that we need in our everyday lives, and especially when you have to do your financial declaration at some point. You need to have a certain sense of numbers. We saw it all over COVID. There were so many terms from statistics that played a role here and there. Just think of the exponential growth. These are not difficult concepts, but if you learn them having in mind that they are useful in your everyday lives, then you will already have a very different approach to it. And this different approach will just make that you are not so much afraid of it. And I think that is a big issue that really has to be addressed at the roots, which is at the level of schools, in the way that this is being taught. I think this is a big part in statistics because people are afraid of it, don't really understand it. And then there is, I said on purpose in the beginning of the interview, twist the data, because of course that's not what is happening in statistics. People often think that, with statistics you can show whatever you like. Well, no, you can't. It is just because of a lack of understanding. When we are making a data analysis, then yes, we look at what the data tells us and we take our conclusions from there. And we don't say anything else than what the data does. Now, of course, like in any field, you have some exceptions where you just try to only focus on that part of the data that arranges you. That exists, but this is not what statistics is all about in general. When you hear about official statistics, well, these are facts. And I think it's really because of this fear and lack of understanding that statistics might have this bad press, which it absolutely should not have, because it is at the basic of so many different things and so many developments in our society.
It just reminds me when I talk to mathematicians, they always say the maths is at the base of everything. But you said statistics, all right? So just a sister of maths, could we say that?
Yeah, a sister of math. I mean, statistics is a particular branch of mathematics that is closest related to probability theory. But it definitely is a part of mathematics. Yeah.
But wasn't there some kind of a definition, I don't know, research council or someone said that actually statistics is not part of maths? Wasn't there something like that, a discussion?
Yeah, well, I mean, this is statistics in its very origins. When you look at the etymological name of statistics, it means basically the science that concerns data, or analyze data related to the state. Oh, that's why it's called statistics. That's the origin. And this is what still many people actually have in mind. As I said, statistics, you think about numbers, boring Excel files. While, no, this is not the case. Of course, at the end, for instance, of a sports tournament like now, we had the World Cup, you will look at stats. That is these statistics. You look at numbers. But this is just one part of statistics. That is what we call descriptive statistics, which allows you to describe a certain fact. But what you do in the bigger picture of statistics, this is you want to quantify uncertainty. Typically what you have in statistics is you have a sample, your data set, and from this sample you want to draw a conclusion about the entire population from which this sample has been drawn. And in order to do this, well, obviously you will do mistakes because it's just one sample for the entire population, just a small part of it. And so statistics is the science that allows you to quantify the uncertainty related to the statements that you say about an entire population. From this, you need probability theory, you need mathematics to do so. With statistics, you can also do predictions, and it is here where there's a strong link with machine learning and also artificial intelligence.
Some of our listeners might have already listened to Aida Horaniec-Ibanez, who is from the Center for Digital and Contemporary History, and she is actually a data scientist, analyst there. So we already discussed a bit machine learning and all that. For those who haven't, I would love to look at it as well. But before we do that, I know you prepared a pub quiz question for our listeners, but related, of course, to statistics and to other things. So can you ask the question, and listeners, remember, the answer will only be at the end of the podcast.
My pub question concerns a question that I think most of us have heard at least once in their life, and especially at school level. So it is the age of the captain problem. I'll just do a version of myself. You are on a ship, you have 26 sheep and 10 horses. The question is, what is the age of the captain? This is, of course, a question to show that not always you have a solution to an exercise. Here, when you do this at school, many pupils, they will then just calculate, add the numbers, and which makes no sense at all. And this question actually is there to show that it's important that we tell our children that they should reflect critically, and not just think because the question is asked that it is meaningful. And so for this very well-known problem, my pub question is, who was the person that actually brought it up for the very first time?
Listeners, please remember that the answer to this question, of course, you can Google it if you want to, but way better way to find it out is to listen to the whole podcast, and at the end we will solve it. And now coming back to what you said, because it just reminded me, for those of you who don't know, I mean, I have really loads of different backgrounds, but one of the backgrounds I have is maths, physics, and computer science. That was my school, secondary school. And exactly one of the most important skills that this school gave me is this critical thinking. So I'm forever grateful to my teachers that did not really look, okay, is this result correct? But they wanted to see how I got there. And if the method of thinking was correct or not. And this is just what is for me at the root of mathematics, and how we should be teaching the children. Exactly this ability to not to look at okay, can you do something plus something, but can you actually think and understand the problem, right?
Yeah, absolutely. And mathematics gives you a way of logical reasoning, which is very essential. And that is also one of the reasons why mathematicians in general, not just data scientists, but mathematicians in general, are so much sought after in industry. Many companies, they want to hire a mathematician just for the way that they are able to solve problems. Of course, data scientists are now sought after everywhere because we have so many data in all aspects of our everyday lives. But mathematicians, they are dearly needed. And so for mathematicians, there are so many unexpected job opportunities that you just, when you are at school, you see mathematics, you think, okay, I have to become a math teacher. What else can I do with mathematics?
Or a researcher.
Or a researcher, yes. But this is something that at that level of high school, maybe you don't yet think of, you don't project
I do
yourself.
know, from that school where I was, there were people who were already,
Okay.
Yes,
yeah.
but it was a very special school,
Okay,
so
yeah.
yes.
With mathematics, you will have so many openings at different companies just for the abilities to solve problems, for the logical reasoning. This is a strength of mathematics.
Okay, but it can also be very theoretical, right?
Of
so
course.
there is always this kind of a discussion that fascinates me, especially when it comes to, physics, maths, statistics. We have the applied part and we have the theoretical part. And I know that you are a professor in applied statistics. So my question, of course, is, can it not be applied? I mean, statistics for us is all this tangible thing, isn't it?
Yeah. This is also a very interesting question. I'll try to say this in a simplified way. Let's put it like this. So basically, in applied statistics, research, what you do is you have a certain concrete problem, a data set that comes likely from another discipline. And what you do is you will either think, okay, do I have an existing method to solve it? Or, which is even nicer, of course, when you don't have this for your mental capacities, if you think, okay, could I develop a new methodology, a new method to approach this, to solve this problem? And so there it's really, it's driven by this particular application. While in theoretical statistics, you are interested in the theoretical mathematical properties of either an existing or a new statistical method that you want to develop. And so there it's really math, probability that you are calculating in order to see, okay, this, for instance, if you have two estimators, this estimator has a better performance than the other estimator because because of these properties. And I myself, I'm now an applied statistician, but I started off as a theoretical statistician. And I can tell you that in my entire PhD thesis, I did not analyze a single data set. So it really was, okay, these are properties that I want to study, and in my thesis I also was interested in solving a conjecture about certain type of statistical quantities, which I was lucky enough to be able to solve. But this was all completely theoretical, mathematical.
So why did you decide to switch?
Well, what actually brought me to switch was when I first started to work with people from other domains. The domain I started off with was psychology. And it kind of, how shall I say, for me, it was really interesting to see what I could gain by having this exchange with people from other fields. And it was also a bit more concrete, tangible, because I could see, okay, what I'm doing here is really for this particular data set. And I know that there I'm helping people in that domain. In theoretical statistics, often it is more the long-term goal. At a longer term, people will be able to use your methodologies, which is great. But here it was really nice for me to see, okay, people from these other domains, they can use this, and also I had a more immediate feeling of why I was doing this. That's what led me to change. But I keep doing also theoretical statistics in my research because I like it. It was really a graduate switch from theoretical to applied statistics.
And it must have been also interesting to learn how to talk to people from different fields, right? Because that I find fascinating, this interdisciplinarity in general. But then I'm sure that these psychologists, they were not really getting what you were trying to tell them.
No, this was really, in the beginning, it took me quite some time to get accustomed to this, to speak the languages of other fields. In the beginning, this is really like, I don't get what they are saying. They don't get what I'm saying. That's tough. But then when you somehow start to overcome this, it's really interesting and it's so enriching because you have to explain your stuff in simple words. This makes you also self-reflect about what you are doing. And the benefits for me in the end have been really nice because I got a deeper understanding of what I am doing, of their needs. So after these first battles, it really became very fascinating to me.
Battles, you called them. Okay, so it was really not an easy task in the beginning.
No, I can give you, I always remember one example, which was the word robust. I was talking with engineers. And of course, for engineers, you had the word robust means something very concrete for them. While for us in statistics, robust rather has the meaning of a procedure is robust when it is not too much influenced by outliers. So we were talking about robust, and after a time we noticed, okay, yeah, no, it's not at all the same that we are talking about. And then we had to start all over again. But after a time we got to it, and then it was a really rewarding experience.
And this is also kind of reminds me of, this idea of talking to politicians and, them taking evidence-based decisions in general, because that's also kind of an outreach and trying to explain your job and trying to educate them and speaking their language, and they have to understand your language. And that's kind of similar. Or would you not compare this interdisciplinarity to the idea of talking to politicians?
It is definitely also comparable, yes. We've seen it, especially in the times of COVID, where this Research Luxembourg has been really established. I was part of it in the very beginning, and so there the politicians really now have been in exchange with scientists, and this was difficult because you had to adapt the language. You could not just speak our scientific jargon because this is too hard to understand. So that was an exercise on both sides. Politicians had to sit down and get an idea of what this actually means. And on the other side, scientists had to find a way to nicely explain, put in simpler words, what they have been doing. This goes a bit into that direction. It's the same type of adapting your style of expressing yourselves. But it is very important because science and politics, they should work together more closely. And I have to say, a very nice action here in Luxembourg is the creation of the cellule scientifique of the parliament, which is really there to help them get the most out of the scientific research. And I think this is a nice way to bond both domains, to have this cellule scientifique.
And how does it work, this cellule? How many people are inside and what's the frequency and all that?
Well, I can't really tell you how many people right now are in there because they are ever growing. I would guess that now they are at about 7 to 9 people, each from a different field of expertise. You have the expert for science, the expert for law. Well, they have several experts for law because this is very important. And what they do is they get a question from a politician, and then they are searching what exists in science on this specific topic, and then they will bring this back to the politician, but in a well-prepared way. But what they also do is they also reach out to us scientists for specific questions or for exchanges. For instance, last year, which was the first year of existence of this cellule, they had organized in May a very first conference, Science Meets Parliaments, on which I was also invited to participate. And that was really nice. It was, the starting point of this engagement between science and politics. And I'm very curious to see how this collaboration will continue over the next years.
Yeah, sounds very interesting. And I also started thinking, as you're Luxembourgish, are you able to describe statistics in Luxembourgish? Are the terms in Luxembourgish for that or not really?
Well, I'm able to do so, but I have to admit that for sure I will have to lend some words from either French or English because, if it's really the technical words, obviously we just don't have them. Though the word that I used before, robust, well, in Luxembourgish we would just say robuste. So that exists.
Okay, at least that. Do you think there is a lot of impact of statistics on politics or should there be more? How do you see it in general?
I personally believe that there should be more. I can give you a very simple example where statistics or data science are used a lot. This is in the world of sports. The professional sports teams, they all hire statisticians, data analysts, because they have recognized that they can just be so much more performing when they are also taking into account what the data tell them. So you can call this data-driven. I personally prefer the word data-aided decision-making. So in sports, they're using this. And we know that sports, they are high-performing. So it just seems logical that policymakers would do the same. So I personally think that there definitely should be more. But again, this creation of the Salut Scientifique shows that they want to go this way. And in times of Corona, we could see that they were really relying on statistics. And I also know that members of parliament themselves, they expressed their wish to have more evidence-based decision-making. So I think we are at a very good point. There is the willingness to go deeper into this, and this can hopefully lead to some very nice future decisions.
Fingers crossed. I think that we would all, be happy to see that happening for sure. You mentioned sports, so I have to go that direction as well. As usual, I still want to go back a little bit on the definition side and all that, but you just went for sports. And I know that this is also an important part of your research in a way. And you published a book. I think there's a second edition coming on sports and statistics. So what is your take on that? Do you analyze all the sports? Is that their favorite sport? And also, are we talking about predictions, or are we just talking about analyzing how it works? All this in one go. Big question.
Okay, that's indeed a big question. So I personally have started off with sports because I'm a sports fan. I love sports. So that's how I got into this. But then I noticed that there is a big need from the side of sports. Last week, for instance, I was at the French INSEP, which is the big place where their elite sports people are being trained for a conference where the goal was precisely to bring together statistics and sports. So, of course, I cannot cover myself all the different types of sports, so you have to specialize. Currently, I'm working on football data, but also on table tennis data, and one particular project on wheelchair basketball, which I personally find extremely interesting. So this past semester, for 3 months, I had a visiting PhD student from Valencia here, who himself is sitting in a wheelchair, and he's playing power chair hockey. So hockey in a wheelchair. And with him, we have...
Wait, hockey in a wheelchair. I haven't heard about it before. So it's like you get special type of ice skates on the wheelchair? Or how do you... hockey.
It's hockey. It's not ice hockey.
Okay,
no,
sorry.
Hockey.
Okay, but outside. And why power? You have special...
it is powered because they are... so in his case, he is not able to move it by himself. So it has a stick.
Okay.
That's why they call it power chair.
Okay.
And he's very good at that. He's actually playing for the Spanish national team. And I was super impressed by this person. Everything that he could do, it was just an amazing, for me also, it was an amazing experience to host him here. And what we did is we have been in contact with a team of wheelchair basketball from Trier. And we wanted to offer them that we help them getting better tactics in how they can play. So we were gathering data from them, and in return we will analyze these data and then give them some indicators of performance, which we hope will help them to get a better performance. As in wheelchair basketball, typically not so much is being done, but it's really fascinating to also learn about that sport. Something else I'm also very much working on is sports medicine. So injury prevention, which is very important, not only for professionals, but also for hobby athletes who are running. They want to not be injured. And so what we try to come up there is to combine statistics and artificial intelligence, which anyway, as I already said, are very intimately linked, in order to provide an algorithm that tells a sportsman, okay, now at this day, your risk of getting injured is so and so high, and these are the main risk factors. And then that sports person can then hopefully act accordingly and prevent injuries. Of course, we know this is never possible all the time, because when you're in a contact sport, you can get in contact. This is not something we can predict. But nevertheless, at the level of training, nutrition, sleep, and so on, we wish to contribute to lowering the amount of injuries. So this is both analysis of the past, prediction of the future, like prediction of injuries or prediction of matches, but also, tactical analysis. So it has actually 3 different components.
Okay, and when it comes to predicting the future, of course, I have to ask, do you bet?
Well, I once had tried with the betting. So this was for the European Championship 2020, which was played in 2021. So we had with the team we are devising an algorithm to predict individual soccer matches, and I was really trying it out how it works by just betting €10 per game. And let's say I was not unsatisfied with the result. Though I have to say it was a difference. It was easier to do it at the group stage than at later stages.
So that probably is something for the model to work on.
Yes, but also it was at later stages, you can predict what is the result after 90 minutes or after 120 minutes. And there I think I did not use it in the best possible way. But of course, we can still try to further improve on this. But I also have to say that for soccer, it is very difficult because our model, which was actually quite good, also in comparison with other models, but we just reached 61% of accuracy in terms of predicting results. Now you might say this is not so high. Well, random guessing would be 33%. So compared to that, it is quite good. But nevertheless, you have a big uncertainty in football. So betting...
Why is that? Why is such a big uncertainty in football?
Well, this is because it's played by humans. That's the nicest thing with all sports.
So that would be all sports?
It's all sports, yes.
Or is it just because it's a team sport, so you have more uncertainty?
It's a team sport, you have more uncertainty, and also because of the events, the goals, they are more rare as opposed to, for instance, basketball or handball. You have more goals, and so if two teams are really of uneven strength, well, when you have more goals to be scored, the stronger team will logically be better off than a less strong team. Well, you can compare this to table tennis. The former rules went to 21 points for winning a set. Now it's up to 11. So when you go up to 21, it's a longer play. So the favorite has much higher chances to win than if it were at until 11. And it's the same with soccer. You have this high uncertainty because it's team, because there are just a few goals, and because it's played by humans. More uncertainty than other sports.
Interesting. For me, definitely, football is difficult to predict because, especially with these big world competitions, I mean, there's always that moment. It's like somebody tells me, this team won against that one, and I just can't believe. It's really surprising. I
mean, just take what has happened here. Argentina, the world champion. Let's remind us all that they lost their very first game against Saudi Arabia. So who would have guessed that, and who would have guessed after their first loss that they would be running up for the title? There are always these things. Psychology also plays an important role. That makes it so hard to predict.
Can you quantify psychology in this particular case?
That is the goal of my research. I would love to be able to do this. This is not easy at all, but a good example again of interdisciplinary research, because for this I want to collaborate with psychologists.
So a lot to do still, but now just kind of rewinding and going back. So we've discussed, you often mentioned people think we do Excel, and that's not the case. So, now let me just stereotypically say how I imagine a statistician and a data scientist. Okay, so a statistician for me is probably still using a blackboard, right, with a lot of formulas there somewhere. And then exactly like a lot of data in an Excel sheet, okay, and doing a lot of kind of manual work, right? And then the data scientist for me is a person writing code in R or Python and getting data from some sources and analyzing, cleaning it, preparing it, and then probably producing some data viz that we all love, right? Mm-hmm. That's how I see it. So tell me, true or false?
Well, it is not so false. It's not so false. It's just that there is a lot of overlap also between the two. Definitely a statistician, especially a mathematical statistician, will have the blackboard or whiteboard. In
exactly,
days.
Blackboard for sure not, but yes, more or less.
Yeah, we still have blackboards at university. We have plenty of blackboards, which is actually very nice to have. But also statisticians, they also get a lot into coding. So in my team, for instance, my PhD students or postdocs, they are doing this. They are doing this a lot. They are coding a lot. They are analyzing the data. So this is why I'm saying there's a lot of intermingling between your descriptions of a data scientist and your description of a statistician.
But you said my postdocs, so you are still traditionally using that board you said that is nice to have, or not? What about you? Do you do a lot of coding as well, personally?
So I personally, I don't do so much of the coding, which is now nice because I really have experts in my team who are definitely better than me, more skilled than myself for doing this. This also has to do with the fact that I really come as a trained mathematician. In the beginning, I was more about the formulas, and now I'm more about the thinking about the methodologies, which new models we could use. I actually like to do a lot in my head. That is a bit peculiar, I know, but that's just how I'm working. I love to work while I'm walking, to think about it, and that's what I really like to do, and I spend a lot of time actually doing this. So the coding, I'm doing less. Writing up, I do this a lot by thinking in my head.
So your classic day, how does it look like? You go for a long walk.
I love to go for walks, yes, but my classic day would be a bit like this. The days are always very different, but I guess many people say that. What is a good time for me to work is actually in the train. I live in Ettelbruck, so from Ettelbruck to Belval, I have 1 hour, 5 minutes train, if all goes very well. But this is a super nice time. It's the best time actually to do research because there is nobody else who comes to ask me anything.
No other PhD students going by train from Ettelbruck, I hope.
No.
You don't have to hide this. I don't want to talk to you.
Well, it's not like that, but it's really, I'm very quiet there. So this 1 hour back and one hour forth and back is really very nice, especially also for writing up the papers. I'm spending a lot of time writing up the results into papers. So train is my good research time, and also the walking between the train station at home, train station at university, that's a great time to think. As I just mentioned before, at the university, there you have a lot of emails. There's a lot of emails to do nowadays. Of course, you also have the teaching. I love to teach. There are also meetings. Well, meetings with my PhD students, with my group, of course, also with colleagues, also with people from outside university, from companies. That also is part of it. And so this is a very nice diversity in the day. Plus one important moment in the day that I have to mention. This is after lunch, table tennis. We have our table tennis group there. So after lunch, this is a holy moment in the day where we like to gather around the table tennis table.
And one of you is gathering the data.
Not yet, but it's so often that we said, we should actually gather the data. Yeah. I myself have done some research in table tennis, but so far we haven't gathered the data, no.
Okay, it's I'm thinking of preventing injuries as well. That you mentioned might be good. I mean, it's not that I'm trying to say that you need it, but at a certain moment, I'm a practicing sports person as well, and I know that there are those moments, right? Yeah. That you kind of think that you can still do everything, and then maybe not necessarily.
So far, fortunately, nothing has happened around the table tennis table.
Okay. And was that table tennis table there when you arrived? Or is that the reason why you decided to move back to Luxembourg?
No, I must say, this is really a coincidence. I arrived last year in November officially, and really just afterwards the table tennis table came there. It's not my influence. People had already decided this. I'm sure, yes. Because our head of department, he's very fond as well of table tennis.
Okay.
So it has been decided. It was very lucky for me that it just arrived at that moment. And it's super nice to have.
Okay, but I wanted to lead up to this question as well. How is it back in Luxembourg? It's amazing, this 20 years of growing, of university from complete scratch, you could say, right? Mm-hmm. I know that you actually did 1 year here before you studied abroad, right? So you really can compare.
Oh, yeah. It's uncomparable. It's amazing what the university has achieved, how it has grown over the time. When I was here in the first year, you have to imagine, at that time, in my class, we were like 25 to 30 people, but this was not just mathematicians, this was also the people studying physics and engineering. We were all together in a class, and we had 80% of our courses were the same. And also, I will never forget the exam period. It was also very peculiar. You did not have like several weeks of exam period. We had all our exams scrambled into 5 days, 5 consecutive days. So there were days where, like in the morning, you had one exam, in the afternoon you had the next exam, and then you rushed home because the next day you had again your subsequent exam. And
so that's why after a year you said that's it.
Well, no, that's not the reason. Actually, the reason was that after a year we were told, we don't have a second year to offer. So at that time you just had 1 year, and which was very nice. But and then it was done. And now you see that so many different bachelors, masters that they have to offer, so many different programs. It's amazing to see how the university has grown. And for me, it's really, I feel so happy to be back, and it's a privilege to be back and now contribute to this university of my home country. It's really a great feeling.
So how do you contribute? Let's now look a little bit at your research. So we already discussed that, there is the sports part that you're looking at and the injuries. Any other interesting interdisciplinary project we could talk about?
Oh, yes. So I'm also working with medical doctors in general, like here from the CHL, but also from the Luxembourg Institute of Health, where, well, it's a bit the same. You try to find the risk factors of certain patients. But then I'm also doing work with engineers from India. They have a lot of data about wind, and they're interested by wind energy. And so what we are looking at is we try to analyze the pattern that the wind has there in order for them to know where they should put windmills and how they should be turned. What is the best possible emplacement? So that's a very interesting collaboration.
Do they already have windmills in India?
They are very much in the production process. I cannot tell you any numbers of what they have. I know that they do have some, but I cannot really tell any numbers. But they have various sites where they measure the wind speed and where they also have their windmills placed, but they really want to improve this. And India is particularly interesting because all over the countries you have very different wind regimes, and it's also depending so much on the season. So this is why India they are so particularly interested by wind energy. That's for one domain of application. Another one, I have a PhD student from Copenhagen, so he's working there and sometimes comes to visit me. And he's from the field of bioinformatics. So he's working on the protein structure prediction problem. How does a protein in our body have to fold three-dimensionally in order for a person to be the healthiest possible, put in simple terms. There, you might be surprised, statistics are also needed because you want to be able to describe the uncertainty behind this folding. You have some data, but you want to be able to say, okay, if we have this amino acid sequence, how likely is it that you get a three-dimensional folding of this and that type? And the uncertainty quantification there is done by means of statistics.
That's a lot of different applications. Basically, whatever people want to calculate in a way, there's going to be some uncertainty as well.
Yeah, in really so many domains you have this uncertainty, and this one I re-insist on this message. Statistics is present in so many different places. For instance, when you go to the hospital, you expect that you get the best possible treatment, right? So, but how is it chosen that a certain treatment, a new treatment, how is a new treatment being considered as being good or not? Well, of course, the doctors, they do clinical studies. This is the main core thing, but at the end of the clinical study, they get data, and then they need statistics in order to say if a new method is at least as good or significantly, a typical word from statistics, significantly better than an old method. This is a very important area, actually. I'm teaching myself to medical students in the bachelor, and I'm giving them plenty of examples where they really need a basic understanding of statistics. They don't have to become experts, not at all, but they have to have a basic understanding of statistics and also of numbers, of risks.
Coming back still to this kind of discussion between data science and statistics, I think I grasped it more or less, but I wanted to understand, are statisticians also cleaning the data, preparing the data, or you're rather just analyzing it?
That again depends. You have some statisticians who are, the mathematical statisticians. What they are doing, they are devising new methods, or they are analyzing the properties of the new methods. And typically, what they do afterwards is that they take a data set to illustrate their purposes. So they will not do the data cleaning. Now, methodological statisticians, it depends. Of course, when you have messy data set, then you might have to do this. Yes, it's also part of the game. It's certainly not the most interesting part of it, but you also have to do it. Again, this is all about what a person is really doing. For instance, now with one of my PhD students, we are gathering a lot of data about handball, because he's a former handball player and wants to make.
So everybody has to do some sport if they want to be your PhD students.
I'm not imposing that, but here, let's say, I was not unhappy that he came with the wish to analyze the data. And yeah, there's a lot of data gathering and cleaning process that has to be done at that level. So statisticians also can be facing that, yes, sure.
And what about data visualization? Do you do that too, or that's for other experts?
I myself am not an expert in data visualization, I have to say. Though I'm using some data visualization, especially when I'm doing outreach or when I'm talking with people from other disciplines, because it's just important to convey your message. But I'm not working myself on this. For this, you really have experts on data visualization to come up with so great new ideas, new ways of showing it.
Yeah, I guess it's also the fact that you're kind of used to certain graphs to show data. You don't have the need to suddenly completely think out of the box, because I think data viz nowadays is more to appeal to people who don't know how to read the graphs, let's say, so that it's kind of more, interactive and understandable for those ones who maybe not are skilled and trained enough to understand it.
Totally right.
Yeah, so that's, again, a different field, I would say. But yeah, talking of fields and talking of different ideas and all that, we have to slowly wrap up, unfortunately. So we would have a lot to discuss. I'm looking at my list of questions. And of course, there's something I would like to ask, but we're running out of time and we have to solve the pub quiz question. So if you can remind our listeners what the question was and then tell us what the answer is.
So the question was, there is this famous problem of how old is the captain when you're on a ship and you have 26 animals of one type, 10 animals of another type. Question then is, how old is the captain, which of course makes no sense. And my question was, this problem that we all have seen in school at some point, who was actually the originator of that problem? And the answer is, very surprisingly, Flaubert, the famous French writer Flaubert. In a letter from 1841 to his sister, he has for the first time come up with this problem, because he really wanted to show, that the meaningless sometimes of certain questions. That's the origin of this problem.
And it's great to see, because of course we have this tendency of separating those two worlds, right? I mean, the world of literature doesn't overlap with the world of mathematics normally. And here it's actually this logical thinking that was suggested, applied, written by Flaubert. So that's very interesting.
It is amazing. Yeah, I myself, when I saw this the first time, I was really amazed. So when you asked me about the pub question, I was thinking a long time. And at some point, I thought, that because of the message that we want our children to think more critically. That's why I chose this pub question.
And it's a great question. Also made me think of correlations as such, and this kind of, difficulty of finding that, right? Like you can see you're saying yes.
I mean, correlation, that's another thing. It would be so important to have just a basic idea of the difference between correlation and causation. Simple example, I can show you a data set where without a problem, you can see that we have a very strong correlation between the length of feet and the capacity of language. And you might be thinking, where is the link? But the thing is, I did not tell you that the data set consists of children. So when they grow, they will know more language, but also their feet are growing. This is a very good example to show the difference between correlation, which might be a spurious correlation that has nothing to do, and causality. And that is also something that if people had a better knowledge of statistics, of numbers in general, then they would be more aware of these things, and they would be less prone to also, fake news.
Yeah, this is a very good point. And in general, we haven't touched upon it because, again, I didn't want to go into that another rabbit hole of machine learning and all that, right? But it just makes me think that the ability to read data, I think, is really crucial. Yeah. Not necessarily understanding the methods you're applying. It can still stay rocket science for us, normal people, I guess. But just that idea, and also understanding, I think, from my side, that, all these data processing that we're doing right now, or the AI and machine learning, human is at the beginning of it.
Yes, absolutely.
So not to think that, okay, now we just let it go and it's going to do something. Of course, it will give us some answers, but for sure, we are actually giving the data. Yes,
we are giving the data. We are also writing the code. Afterwards, the machine is capable of learning in an amazing way. I mean, you can think of the recent ChatGPT and other times of learning. It's incredible. But at the end of the day, it's us who tell the machine that they should do it. And therefore, it's also so important that machine learning is often described as a black box, that we need interpretable machine learning. Because in the end, when a machine has learned something and has given us an output, we still must be able to know why did it come to this conclusion. Interpretable machine learning is an important research domain nowadays that also brings statisticians close into the picture, because you want to be able to understand what a machine learning algorithm does. And if you're able to understand this, then this is also a way to improve how AI works, especially when you think of self-driving cars and so on. We must be able to understand why they take which decision.
And we also must be able to get more than 60% of accuracy, because
yes.
In football, okay, but not with self-driving cars.
No. That definitely we must get a much higher accuracy. Yes,
exactly.
Fully agree.
So I guess we leave it here, and we're going to probably in a couple of years regroup again, and I'll ask you all about where you are with your research and whether you still call yourself a statistician or maybe now data scientist or statistician 2.0, you said.
Yeah, that would be the best, yes.
Okay, thank you very much, Christoph, for today.
Thank you very much.
Okay, and this is it for today. As usual, don't forget to subscribe, to follow us, rate us, check what we're writing on Twitter, on LinkedIn, and actually we started Instagram as well. So if ever you are there, you can also check what is happening. There's not much going on, but there will be, hopefully soon. And this was SciLux, powered by Research Luxembourg, and my name is Hanna Siemaszko.